Hello everyone, welcome to today's session. Today we'll talk about Snowflake architecture and how it is different when compared to some of the other traditional architectures. So first let's look at the traditional architectures. Uh, we all have used at some point of time, these architectures, or we have worked on certain databases which have been using this kind of architecture. Especially if you have worked on any of the older databases or RDBMS, it worked on the shared disk architecture where there was just one single instance and there were multiple databases created on that. And all of them used to share the same disk. This was the shared disk architecture. Okay. And then as the technology evolved, we started getting some of the new architectures which were like shared nothing. Shared nothing as in every node would have its own compute and it would have its own storage along with it. Like if you can recollect how our Hadoop architectures were, like we had a data node which consisted of the compute power as well as the storage power. And in case you wanted to scale your just the storage, you would need a separate data node, and it would end up resulting in additional compute as well, which eventually required, or which eventually resulted in more cost. So the scaling was not separate. The compute and the storage scaling was not separate. And that was the biggest disadvantage of these kind of architectures. So previously, all the architectures were such that if you want to scale your storage, you would eventually end up scaling your compute as well. And eventually that would result in additional cost. And that is where, Snowflake architecture is much different than this. So we'll now have a look at the Snowflake architecture and how it is different as compared to these. So at a high level, this is a very high level picture of how the Snowflake architecture is. And I'll try to break it down into pieces to make this much more simpler so that everyone can understand it. The Snowflake architecture is divided into three main parts or three main layers. First is the services layer, the second is the compute layer, and the third is the storage layer. Okay. So we'll look at all of these layers one by one. Okay. The first is the services layer. So services layer is it's basically the brain of Snowflake, and in our previous our videos or the previous sessions we have seen this. The services layer is the brain of Snowflake. It is responsible for a lot of activities. Basically, it coordinates all the services like your complete infrastructure management service, your data metadata management, your authentication, access control, your query optimization. So this is the first entry point for the user. So user, when he fires the query, it will come through this services layer to the next layers. Okay. So this is the first is the services layer. Second is the compute layer where the actual query processing takes place. And finally, the third layer is the storage layer where the data is actually stored. Okay, so these are the three layers. So when a query is fired, it comes from the services layer, it goes to the compute layer, and then from compute, it goes to storage. Now, what's so different with this architecture is your compute and your storage is separate. These two are completely separate layers. Uh, so that if you want to scale compute, you don't really need to scale your storage, or even vice versa. If you want to scale your storage, you don't have to worry about scaling your compute. So these two are separate layers. And how it is done in Snowflake. Okay, we'll now do a bit deep dive into these layers. We'll try to understand what really happens in the back end of these. So let's first talk about the compute layer. Compute layer are nothing but the virtual warehouses in Snowflake. Okay, and we can create separate virtual warehouses. Now if you see in this diagram, you will see different sizes virtual warehouses. Okay, uh, these are like separate warehouses and they all can access the same storage. So it's not that the storage is dedicated for any of the warehouse. Okay, so as we saw right previously, in the traditional architectures it was like, the storage was attached to a particular compute node. Here it's not the case. Your warehouses are separate, they are not attached to any of the storage. So any warehouse, okay, any of these warehouse can access any data which is there on the storage. Okay, so even if there is some data which is stored through a particular warehouse. Okay, now in the diagram you can see there is a warehouse for ETL, there is a warehouse for analytics. Okay, now even if some data is inserted by the ETL virtual warehouse, that data can be used by the analytics warehouse. Okay, what what this means is your compute and storage are not attached to each other. So any of the warehouse can use any of the storage. That is number one. Second, the virtual warehouse, which is the compute, right? It is easily scalable. You can scale this, and it comes with various types of sizing. What Snowflake offers is a t-shirt sizing for warehouses. So there can be smaller warehouse, there can be medium size warehouse, there can be larger warehouse. Okay, we'll do a deep dive session for this separately. But for this architecture, just try to understand this virtual warehouses come in different sizes, and based on the workload, this can be resized, right? So we can go from small to medium, medium to large, right? And the performance will improve accordingly. It gets almost a linear kind of a performance with increase in the warehouse size. At the same time, we can also have multi-cluster warehouses, right? If you see the virtual warehouse for analytics, you can see there are two clusters. That is, in this virtual warehouse, you can have multiple clusters. So there is a scale out as well. So it's not just scale up, but Snowflake also supports the scale out. Okay, so this is how the compute layer works in. So if you're processing any query, right, the query will come from the services layer, it will go to the compute layer, it will get executed. The actual query processing will happen in the compute. And for the final layer, right, from where the data comes from, the data is this in this final storage layer. Now this is built on top of the uh, whichever cloud you are using. It is based on top of the cloud storage. So if you have Snowflake on top of AWS, this storage is nothing but the AWS S3 storage, right? So and Snowflake has its own file formats. Okay, it has own proprietary storage, but this is on top of S3. So all the data will reside in the Snowflake storage. So if you want to access some data, you will first have to move it from S3 to Snowflake. Okay, you will have to move the data from S3 to Snowflake, and then the data will be accessed. Okay, so that is how the storage and compute would work. Now, since it is an AWS S3 storage, it can scale. Okay? It can scale easily. Like S3 is highly durable, highly available, scalable, right? So you get all the properties and features of S3. So you don't have to worry about scalability or durability or availability of this. So this storage, Snowflake storage is on top of S3. In one of our next sessions, right, we'll have a look at how this data is stored. Okay, there is a concept called micro partitions and all those things. We'll have a look at that. But as of now, for this lecture, just remember the Snowflake architecture at a high level. There are three services layer. Sorry, there are three layers: services layer, compute layer, and the storage layer. And the most important part is the compute and the storage are independently scalable. Okay, that's the most unique part. These two are independently scalable, and that is why, right, this whole architecture is called as a multi-cluster shared data architecture. Multi-cluster as in you can get multiple virtual warehouses. It can have multiple clusters within that for getting the scaling out kind of a feature, but the data is shared. So it's a multi-cluster, and at the same time it's a shared data. So it's a very different architecture which is very specific to Snowflake, and that is what gives the real power to Snowflake, which makes it easy to scale, and you don't and you pay separately for your compute. You can scale it separately with your storage. So all these specific features are because of this architecture.